Hello, everyone. Beginning a new lecture today on Chapter 6, Section 2. So this is continuing where we had left off. Here you can find this information on page 332 of the book. And we're going to examine finding data value, an X value, or a cut score, right? Sometimes we'll refer to this as a critical value. But the basic formula is x is equal to z. All right, my z is with a little cross like that, so I don't get them confused with my 2's. All right, so anyhow, the formula is x is equal to z times sigma plus mu. And that is basically just taking the formula for computing a z-score, right, which involves z, x, mu, and sigma, right? And rearranging that same exact formula for x and solving for that. So basically here, if we have the z-score, we can just plug it into this side and we'll be able to calculate x. The other version of the formula has z on the left-hand side and x on the right-hand side. And so that's more useful if you have the x value and you want the z value. So anyhow, the steps are listed on page 332 are, of course, what we sketch the distribution curve and we label either the x value or the z value. It doesn't matter, right? We just want to essentially conceptualize what's going on so that we are thinking about the correct area. So for instance, if we want to know, what's the cutoff score for the upper 10%, we would be shading this region here. It doesn't matter whether I label this as 1 or 237. Doesn't matter. Just 1, I would be talking about the z-score, and the 237, I might be talking about the raw data. But who knows? Who cares? I just want the general picture. I want the sketch. It doesn't have to be a perfect diagram. Then we're going to find the z value given the probability or the area, right? Whatever it is that we're asked about. We're thinking about this area, whatever that is. And we're going to do that reverse lookup using the table. So just like we're using the reverse formula here, we're going to use the reverse lookup. And then that's the last thing that we're going to do is we're going to take that z value that we get out of the table. Remember, we have the p value, or we have the area underneath the curve. We reverse look up the z value, and then we're taking that z value and from there calculating the x value. So that is kind of like the, well, I mean, it's the reverse process. It's the mirror image or backward map process of what we normally do. So normally we have the data value and we want to find its associated probability. Here we're finding, we're given the probability and finding the associated data value. Okay, so I'm going to move on to the first example. That is example 6-9, we found on page 333. Of course, this is in chapter 6, section 2. And let me go ahead and read the example out of the book. So, oh well, throwing things on the ground. More things throwing on the ground. All right, so here it is, example 6-9, Police Academy qualifications. So it says, to qualify for Police Academy, candidates must score in the top 10% on a general abilities test. Assume that the test scores are normally distributed and the test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. All right, so that is why I have written here mu is equal to 200, sigma is equal to 20, and then I wrote it as the cut score, right? What is the minimum score, right? So what's the bare minimum? What's the bar that you have to clear? What is the lowest score that you have to get in order to pass this test? Because we have to be in the top 10%, right? That's the assumption here. Okay, so one of the things that I like to do when I'm problem solving is I like to pretend that it's me. You know, I like to be a stakeholder in the problem. So I'm thinking to myself, what do I got to do to get an A, right? What score do I have to get in order to be in the top 10%? That would be, 90th percentile, right? So here, steps one, I'm going to label them are going to be to sketch the distribution curve. There, it's roughly a bell-shaped curve, right? It doesn't matter because I'm not going to go into super amount of detail on this. All right, so let's see. That would be average. I want to be above average. I want to be in the top 10%. So, I want to get this score, whatever this is, whether it's my X score or my Z score, or better than that, right? And what's the deal? That area is going to be exactly 10%. And remember, the Z table goes out to 4 digits past the decimal point, so that's why I'm writing it as 0.1000, but 0.10 or 0.1, it doesn't matter. You can say either way, it's the top 10%, right? So now let's go ahead and get our Z table. Yes. All right, so what are we going to do here? Remember, we're going to do the reverse lookup. Now, that means we're going to be finding 10%, 0.1000, or as close as we can to it, in the interior of the table, and then from there looking at what row and what column it is in, and from there getting out the Z value. So we're going to basically do the reverse of what we usually do. I'll try to link the previous video to that. Okay, so let's see. I see 0.968, I see 0.1003, and I see 0.0985. And in the other video, oh, sorry, barely can see it here. In the other video, I jokingly say I have no idea which one of these is closer to exactly 0.1000, but after giving it several hours of careful thought, I've come up with this one here. It's 0.1003 is closer than 1020, that's getting further away, and 985, that's 15 away, whereas that's only 3 away. Okay, so these are the simple things that I get bogged down on. All right, and so anyway, now I'm forgetting the whole point of this. There's 0.103, so we can't get exactly 0.1000, but we get as close as we can to it. And going out to the row, we see that's the negative 1.2, and up to the column, that's the 0.08 column. And so that is our Z value. And so on this table, I actually will write the Z value. I'll say it's negative 1.28. And I'll remind us that that's a Z value. And this is one that we're going to actually kind of keep coming back to. This is one that we're going to see occur over and over and over again. So that one, well, just in the future, for future reference, when we see 1.28 or negative 1.28, hang on one second. Oh, all right. Good teaching moment. So we'll pause here. Maybe stop the video. Well, at least pause. Okay.